What force would be needed to produce an acceleration of 4 meter per second square in a ball of 6 kgs? So the acceleration in this case is 4 meter per second square. We call it as A. And the mass is 6 kgs. Mass, which we say is m, is 6 kg. We know the formula by Newton's second law. We have F, force, equal to mass into acceleration. Let's put the values. Mass is 6, here is 6, acceleration is 4. So force will be 24. Now the SI unit of force is Newton, so the force required here is 24 newtons. What is the acceleration produced by a force of 12 newtons exerted on an object of mass 3 kgs? So in this sum we need to find the acceleration. This is the question, which we say as A is our question. Now the force is 12 newtons, so force, which we'll say is F, is 12 newtons, and the object of mass 3 kgs. So mass, which we write as m, is 3 kg. And we know the formula by Newton's second law. We have F equal to m into A. The force is 12, the mass is 3, and the acceleration we need to find. So the A will be, acceleration will be 12 over 3, that is 4 is the acceleration. And we know the unit of acceleration is meter per second square. So in this sum, the answer is acceleration is 4 meter per second square. Calculate the force required to impart to a car of velocity 30 meters per second in 10 seconds starting from rest. The mass of the car is 1500 kgs. Now we start first with the mass. The mass is given of the car as 1500 kgs. The next thing, it's starting from rest, means the initial velocity is equal to 0, which is given as u is equal to 0 meter per second. Here, to impart a car of velocity 30 meter per second, that means the final velocity of the car, which we call as v, is 30 meter per second. And this is 10 seconds. The time is 10 seconds. So we put time, which we write as t equal to 10 seconds. Now we need to find force. And by Newton's second law, force is mass into acceleration. If you notice here, we have the mass is given here. However, we do not know the acceleration. So we have to go ahead and find the acceleration. Formula for acceleration, A equal to V, final velocity, minus initial velocity over t. So acceleration equal to, this is our V, 30, minus u is 0, over time is 10 seconds. So acceleration is 30 over 10, which is 3 meter per second square. So let's go ahead and substitute. So F equal to, our mass is 1500, which I'm putting here, and our acceleration, we have found it here, 3 meter per second. So this 3 meter per second. So we have force is equal to 4500 newtons. A car of mass 2400 kgs, so this is a m, moving with a velocity of 20 meter per second, so this is u, is stopped, which means the v is 0. It has come to rest in 10 seconds, so this is time. On applying brakes, calculate the retardation and the retarding force. Retardation means we've got to calculate A, and the retarding force is we have to calculate F. So let's write down our information. So the mass of this car, which we'll say m, is 2400 kg. Moving with velocity 20 meters per second, which means initial velocity equal to 20 meter per second. Now here they said the body has stopped. The body has stopped means the final velocity is 0 meter per second, and in time t seconds. So we have time, which we call t, is 10 seconds. So again, by Newton's second law, we have force equal to mass into acceleration. The mass is given to us, however the acceleration is not given to us. Just to go over this sum again, the body initially had a velocity of 20 meter per second. Then there is a force applied and the body is stopped. Now the body becomes 0 meter per second, and this takes 10 seconds. So this is u, this is v. We know the formula for acceleration is v minus u over t. So acceleration is v is 0 because it has stopped, u is minus 20, which is given here, over time is 10. So acceleration is minus 20 over 10, which is minus 2 meter per second square. Why did we get this negative sign? We got negative sign because this object is retarding. It is slowing down. It is stopping. So the acceleration is negative. Negative acceleration is called retardation. Now let's go ahead and substitute here. We know our mass is 2400 and we have calculated our acceleration as minus 2. So we do into minus 2. So we have F equal to 4800 newtons, but negative. Negative because the body has stopped. The force is acting in the opposite direction, and this is called retardation. And the force will be called the retarding force. So retarding force here is 4800 newtons. What is the force which produces an acceleration of 5 meter per second square in a body of 20 grams? So the force we need to find. So force, that is the F, is our question. This is our acceleration and this 20 is our mass. So acceleration 5 meter per second square, and mass, which is m, is 20 grams. Now this 20 gram is not SI unit. We need to convert it into kg. So we need to divide it by 1000 to make it into kgs. So we did 20 over 1000 kgs. Now back again by the second law, we have F equal to m into A. F we do not know. Our mass is 20 over 1000. And the acceleration we saw is 5. Here is the acceleration given to us. Here is the acceleration. And now we calculate this equal to, we cut this out. Then this is 1. And this would be 50. This would be 1. This would be 10. So 1 by 10, that is 0.1 newtons. A body of mass 5 kg, so this is mass, is moving with a velocity of 10 meter per second. So this is initial velocity. A force is applied to it so that in 25 seconds, so this is time, it attains a velocity of 35 meter per second. This is final velocity. Calculate the force. F has to be calculated. Let's write down the information. So we have mass of the body, which is m, equal to 5 kg. We have 10, it had an initial velocity of 10 meter per second. So initial velocity equal to 10 meter per second, and this is in 25 seconds. So the time here t is 25 seconds. It attains a velocity of 35 meter per second, which means final velocity is equal to 35 meter per second. We need to find the force. Let me just go over the sum again. So this is a body. So this body had an initial velocity of 10 meter per second. Then a force is applied, and because a force is applied, the velocity increases to 35 meter per second. All this happens in a time of 25 seconds. We need to calculate the force applied. So this is our U, this is V. So first we know that F by Newton's second law, here you need to write Newton's second law. We have F equal to M into A. Now the mass we know, but we need to calculate the acceleration. For acceleration, we'll do A equal to V minus U over T. So acceleration is V is 35. Here V, this is the U minus 25 over time is 25 seconds. So that is 10 over 25 meter per second square is acceleration. Here was a mistake. This is the time and your U is here. U is 10 meter per second. So I need to put 10 meter per second. Okay, so 35 minus 10, U is 10. 35 minus 10 is 25 over 25. That is 1 meter per second square is acceleration. So we have force. We know mass is 5 into acceleration is 1. So force is 5 newtons. A 1000 kg vehicle, so this is mass, is moving with a speed of 20 meter per second. So this is initial velocity, is brought to rest. So V equal to 0. In a distance of 50 meters, so this is the distance S. We need to find acceleration and the force acting on the body. So let's write our information. So mass, which is M, equal to 1000 kg. Then we have initial velocity. See, moving with a velocity of 20 meter per second. So our initial velocity, which we denote as U, is 20 meter per second, is brought to rest. So final velocity will be 0. V will be 0 meter per second in a distance of 50 meters. So distance here, time is not given. Here distance, which we say S, is 50 meters. We need to find acceleration. We have three equations of motion. One is V equal to U plus 80. Then the other one we have S equal to UT plus half AT square. And then we have V square equal to U square plus 2AS. Now which of these are we going to use to find acceleration? Let us look up at the first one. Here, do we know final velocity? Yes, we know this. We also have initial velocity, but we don't have acceleration, nor do we have time. So two unknowns, so we cannot use this equation. Let us go to the second one. Do we have distance? Yes, we have distance. We have initial velocity, but we don't have time, and we don't have acceleration. So two things unknown. We can't work with this either. Let us look at this one. We have final velocity, we have initial velocity, we have distance, and we only need to find A. There is only one unknown. So we are going to start with this equation. This is how you have to decide which equation you're going to start with. So I'm going to start with this and write V square equal to U square plus 2AS. Now the V is given here as 0. So 0 square equal to U is here given as 20. 20 square plus 2, acceleration I do not know, and the distance is given here as 50. So I will put 50 here. So 0 equal to 20 square is 400 plus 2 into 50 is 100. 100 into acceleration. So we have minus 400 equal to 100A. So your A is minus 400 over 100. And your acceleration is minus 4 meter per second square. Why did the acceleration come negative? Because if you notice, what has happened here is, first the body was at 20 meter per second. And then the velocity came to 0 meter per second. So the body has slowed down. And if the body has slowed down, its velocity has decreased, means there is retardation. Retardation means negative acceleration. If a body slows down, your acceleration should come negative. That is why here our acceleration in this case has come negative. Now we go ahead and find the force. Force is mass into acceleration. We saw the mass is 1000 and the acceleration is minus 4. So our force is minus 4000 newtons. Again we got our force negative because it was a retardation. Here the force is acting opposite to the motion. Hence we got it negative. There is retardation. The body is slowing down. We need to write here force is opposite to motion. Hence the negative sign. It is called a retarding force.